Hello viewers, Said Ishfaq Noor with the topic carbon and its compounds, class 10 science, and I would be restricting my this lecture to bonding in carbon and covalent bond. So let's straightway go to our carbon. As all of we know that carbon has maintained a spatial status in the field of chemistry because of its two unique properties. Number one, its ability to form long chain compounds. It links number of carbon atoms together, and because of this, the whole globe has been revolutionized. The pharmaceuticals, the drugs, the textile products. Um, all are the outcome of this the phenomenon, this property of catenation, ability to form long chain compounds. And another important unique property of carbon is it and its compounds is the that they exhibit isomerism. They form isomers. They form compounds of same molecular formula but different spatial arrangement of their constituent atoms. Moving on to our actual topic, that is the bonding in carbon. What is the bonding structure in carbon? So before knowing that, we need to understand what is a chemical bond. Why chemical bonding? The answer to this question lies in the world around us. It is instructive to imagine what the world would have looked like without chemical bonds. Without chemical bonds, the world would have only free atoms or ions. We would not have the amazing variety of substances that we see around us. There would have been no water, no food, and there would be no life. So the atoms, molecules, when they combine together, they result in the formation of molecules. And these molecules of various shapes, various geometries, they lead to the formation of different material and various substances that are around us. So you have understood why bonding is important. If you just see on the screen, to bind atoms, we need glue. We need some vital force to bind atoms together. The electrons present in atoms provide that magical glue. How do ions, how do they form a bond? It's because of the electrons present in them. It's not the entire electrons. Say the atomic number of carbon is 6, so we are having 6 electrons. No, only the electrons that are present in the outermost shell participate in the formation of a bond, in the formation of a chemical bond. Say for example, we have carbon has 4 electrons in the outermost shell. 4 electrons participate. Oxygen has 6 electrons in its outermost shell. Magnesium has 2 electrons in its outermost shell. Only these, the electrons present in the outermost shell, participate in the bond formation. In other words, we say we need sufficient electron density between the nuclei of two atoms to create a bond. So moving on to our actual topic, that is bonding in carbon. To understand the bonding in carbon, we need to recollect, to recapitulate some of the concepts that we have already studied in our previous classes. See, we have studied electrovalent compounds. We have heard about covalent compounds. Electrovalent compounds, if we just recall, these are the compounds which are formed due by gain or loss of electrons. Electrovalent compounds, and the compounds which are formed by the sharing of electrons, we call them as covalent compounds. The bond between the two electrovalent compounds is one metal and a non-metal, and in case of covalent compounds, the bond is between two non-metals. The best example in front of us is the sodium chloride, the hydrochloric acid, sodium chloride. The bond between them is the electrovalent bond, and in between HCl it is a covalent bond. So let's focus back onto our carbon. See, carbon has an atomic number 6 with its 4 electrons in its outermost shell. To attain stability, carbon either has to gain 4 electrons or lose 4 electrons. Let me make this concept first clear. What do we mean by attaining stability? By attaining stability, we mean that the electrons present in the outermost shell for a bond formation, it is necessary to complete the octet. The octet rule states that when chemical bonds are formed, the atoms involved in bond formation achieve the electronic configuration of a noble gas. The noble gases excepting helium have 8 electrons in their outermost shell, be it neon, argon, krypton, xenon or radon. This rule applies to both covalent and ionic compounds. So in case of carbon, to attain stability, carbon has to gain 4 electrons or lose 4 electrons. If it gains 4 electrons and becomes carbon 4 negative ion, it will be difficult for the nucleus with 6 protons to hold on the 10 electrons. Similarly, if the carbon loses 4 electrons and becomes carbon 4 positive cation, a large amount of energy is required to remove 4 electrons, leaving behind 6 protons in the nucleus holding on to just 2 electrons. So, carbon has another method to share electrons. Not only carbon, hydrogen, oxygen, nitrogen, they achieve noble gas configuration through this. So, we can moving on to this diagram again. See, carbon has 4 valence electron. On the left side you see 4 single bonds. So carbon can form 4 bonds. 4 single bonds are attached to the carbon. And on the right side of the diagram, we know that hydrogen, the atomic number of hydrogen is 1. Hydrogen has 1 electron in its outermost shell, and the same outermost electron is its valence electron. So 4 hydrogen atoms having one valence electron in their outermost shell create bond with the 4 valence electrons of the carbon, as you can see in the diagram. 4 hydrogen atoms attached to the carbon. Carbon has valency of 4. That's why carbon forms methane, CH4, as you saw in the previous screenshot. It was shown by Van Thoof and Liebel that the 4 valencies of carbon are pointed towards 4 corners of a tetrahedron. This is so in a molecule like methane as well as in diamond. Now let's come to the covalent bond. As we know that noble gases have complete outer electron shells, which makes them stable. In order to be stable, atoms come together and form a bond to achieve the noble gas configuration. This coming together and sharing of electron pairs. An atom of hydrogen comes in contact with an atom of hydrogen. It results in the formation of a chemical bond that we call as covalent bond. Atom of chlorine comes in contact with an atom of chlorine, so we call this as covalent bond. And we'll be dealing certain examples of covalent bond as well. The chemical bond, so let's reflect. A covalent bond is formed by the sharing of an electron pair between 2 atoms, so that both the atoms get their octet complete. We call that as an covalent bond. The molecules formed as a result of sharing of electron between atoms are called covalent molecules. So we have different types of covalent bonds. Just focus on hydrogen, oxygen and nitrogen. We have single covalent bonds. They are formed by sharing 1 electron pair between 2 atoms, in which each atom contributes 1 electron, as you can see in the example of hydrogen. We have double covalent bonds. They are formed by the sharing of 2 electron pairs, 2 atoms, in which each atom contribute to 2 electrons. We have see the example, oxygen atom forms covalently bonds by 2 atoms of oxygen sharing 2 pair of electrons. Similarly, nitrogen atom forms covalent bond, and we call them as triple covalent bonds. They are formed by the sharing of 3 electron pair between 2 atoms, in which each atom contributes 3 electron. The 2 nitrogen atoms share 3 pairs of electrons. Thank you. We can also just check in the difference between the covalent and The ionic bond, we say ionic bond, these are formed by the transfer of electrons from one atom to another atom, leading to the formation of positively charged and negatively charged species, to whom we call as cations and anions. In case of, just see the example of NaCl. In the formation of NaCl, sodium loses electron to form Na positive, chlorine gains electron to form Cl negative, and electrostatic force of attraction between oppositely charged species is created, resulting in the formation of ionic bond. In case of HCl, on the right side, bond between hydrogen and chlorine is purely covalent, because both are non-metals. There is difference in electronegativity of hydrogen and chlorine. Shared electrons pair get attracted towards chlorine due to this, polarity is induced in the bond. Hence hydrogen chloride can be termed as polar bond. Thank you.